Hello, we're going to learn about similar polygons today. Similar figures. Same shape, but not necessarily the same size. Symbol for similarity is this curved line. This symbol is called similar, the similarity. You can use ratios and proportions to decide if two polygons are similar and to solve for unknown side lengths. Similar polygons. Two polygons whose corresponding angles are congruent and the lengths of corresponding sides are proportional. So let's look at an example. This symbol right here, like a curve, that is a similarity sign. So this means ABCD is similar to GHIJ. So this trapezoid is similar to this trapezoid. And corresponding means same spot. So if you look at this angle A and G, corresponding angles are congruent. So that means same, 90, 90. Angle B is congruent to angle H. Angle C is congruent to angle I. Angle D is congruent to angle J. So if two polygons are similar, that means their corresponding angles are congruent. Now, the corresponding sides are not congruent necessarily. They're proportional, which means the angles are inside are congruent, they're same, but the sides are proportional. So if you have AB, this length, this side is corresponding to GH right here, the same spot that's corresponding. They're going to have same ratio. This to this, and then BC to HI, they're going to have same ratio. CD right here is going to be same ratio to IJ here. And then AD right here is corresponding to this. They're going to have same ratio. So they're going to be proportional to each other. They're not going to be congruent. So similar polygon is same shape but different size. But the angles inside for each corresponding angles, they are congruent. Writing similarity statements. Similarity statements. We're going to write JKLMN is similar to STUVW. List all the pairs of congruent angles. So that will be J and S. You see that they are first ones. Those are corresponding, congruent. So the J and S, the first two right here, first J and first angle and first angle here, they're going to be congruent to each other. So please write angle J is congruent to angle S. Angle K and angle T, they're congruent because they're the second angle. Angle L, angle U is congruent. Angle M, angle V congruent. Angle N and angle W are congruent. So the angles are congruent, the corresponding angles. We need to write a statement of proportionality that compares the ratio of two corresponding sides. So this is important. You need to write that JK is corresponding to ST and they are proportional. So JK, ST, and then KL to TU, they are proportional. So you have to go left to right, top, bottom, left, right, left, right. This is the left. All the left ones are on the top, all the right ones on the bottom. And then you're going to write LN is proportion to UV. MN is VW. And then NJ is proportional to WS. And then you can actually draw and you can actually compare and see which ones are corresponding. So please write this down. This is very important, that how you write the statement of proportionality. Now, next thing we're going to talk about is similar polygons has scale factor. If two polygons are similar, then the ratio of the lengths of two corresponding sides is called the scale factor. So the ratio you have is called scale factor. So let's say triangle ABC is similar. This is the similar symbol. It's to triangle XYZ. If you look at these two triangles, these are similar. The angles are congruent, but the sides are proportional. So if you look at BC to YZ, these are corresponding. This side, these are corresponding. 20 to 8. 20 to 8, if you reduce, that's 5 to 2 ratio. This ratio, this proportion for these two polygons is called scale factor. So the scale factor for this figure is 5 to 2. So if you do 15 to 6, that's 5 to 2 reduced. 25 to 10, that's 5 to 2 reduced. So 5 to 2, you have to reduce. And that's the scale factor of the similar triangles. Perimeter. If two polygons are similar, then the perimeters have the same scale factor as the sides. So if you have KLMN, quadrilateral, is similar to PQRS, then if you add all the sides on the top, KL, LM, MN, and NK, all the sides, all the perimeter, all the sides, this is all the perimeters, to all the perimeters on the bottom. So if you add up all the sides for the first quadrilateral, put that on the top, and then all the perimeters for the bottom, this one, this quadrant on the bottom, the ratio of perimeter for this to this is going to be the same ratio if you write the same scale factor as the sides. So if you write the corresponding sides, they're going to have same scale factor. If you put the perimeter of this quadrilateral to perimeter of this, they're going to have the same scale factor. So this section right here are the perimeters. Scale factors the same, they're proportional, same ratio. Or if you just choose corresponding sides, they're going to be same ratio. So similar polygons have, let's look at the scale factor for these two. Here you have 5 to 10, X, 6, and Y. So you can actually use proportion to find the missing side. So this is corresponding, 2 and 6. They are same thing. And then we're looking for 5 and X. These are same spot. These are corresponding. So 5 to X equals 2 to 6. They're going to have same ratio. Cross, multiply, and divide. So 5 times 6 is 30. 2X divided by 2, 15. So this X is 15. Once you find the X, I want you to find the Y. So if you have 10 to 2, right? 10 to 2, you can use 10 to 2 this way also. If you have 10 to 2, Y to 6, you can use it that way too. Because Y and 10 to 2 is this side over 2 and this side over this. You can use that also to find the Y. So cross, multiply, and divide. 10 times 6 is 60, divided by 2, 30. Or you can just use scale factor of 1 to 3. So 2 to 6 is the ratio, and you can actually reduce 1 to 3. So you can use 1 to 3 to find the missing side also. So the X is 15, Y is 30. And as you can see that it's 3 times. So 5 times 3 is 15, 10 times 3 is 30. So this is 3 times bigger than this one, the side, the proportion wise. So you can multiply 3 here to get the X, 3 here, get the Y. Let's take a look at the next one. Is ABC, triangle ABC is similar to DEF? And let's explain. So if they have the same scale factor, then it is similar, but you have to check every single corresponding size. All three sides has to be proportional. So here you have AB that is corresponding to DE right here, because you kind of have to turn this. This is kind of turned, so you gotta bring this over here if you look at the shape. So right here, these two are 12 to 6 ratio, which is 2 to 1 ratio. And then we're going to do AC with to here. This is right here. AC and DF, they are corresponding 10 to 5, which is 2 to 1 ratio. And then BC to EF, that's 13 to 7, which is not 2 to 1 ratio. So you need to check all three sides and make sure they are all have same scale factor 2 to 1. This one doesn't. So this is not similar triangles. So all sides has to be proportional. Let's take a look at the next similar shapes. Here you have similar polygons. We're going to verify if they're similar, and you must have to do these three things. Identify pairs of congruent angles, compare the ratios of corresponding sides, and if similar, write the similarity statement and scale factor. So these are the three things that you need to do to verify if two polygons are similar. So let's do that. Angle E, angle T are congruent. Angle A and angle U are congruent. Angle B and angle V is congruent. Angle C and angle R are congruent. Angle D and angle S are congruent. So make sure you pick the corresponding sides. So maybe you should turn this and then write it down. And then we're going to compare the ratio of corresponding side. I want you to write like this. So EA to TU is corresponding. AB to UV is corresponding. BC, VR corresponding. CD, RS corresponding. DE, ST corresponding. And then we're going to write the ratio. So 12, 6, 18, 9, 18, 9, 18, 9, 12, 6. So if you look at each corresponding size, they have 2 to 1 same scale factor. If all corresponding sides have same scale factor 2 to 1, then you're going to write scale factor is 2 to 1. Then you're going to write the similarity statement. EABCD is similar to TUVRS. So this will be your similarity statement. So please write this down.